All right, so good afternoon, everyone. Welcome to the third day of our blockchain development bootcamp. So I hope you enjoyed the last session, and then we'll be continuing today's session. So I'll hand over to our instructor, person of Mr. Justin Obi. All right, so sir.
All right. Hi, everyone. Happy to be here again. As rightly introduced, my name is Justin Obi, a software engineer and also a lifetime learner. So, I'll be handling us on today's section, which is we're going to be talking about how to secure blockchain programs, and that entails working with cryptography, hashing, some data, then how to work with some tools like Truffle and Ganache. So it promises to be an interesting session. Before I proceed, I would like to. There's some stuff I left out in our first session, which uh, was supposed to be like the resources to practice what was taught during our last session. So I'm going to be sharing it on the comment section. There's some couple of links I'll be dropping. All right, so hope you can see the link. Okay, Dami,
Okay, you can
if
drop it in the comments.
you got a comment,
Yeah, this is fine.
okay, you can,
Should I do that?
yes, you can help me do that.
All right, so
Okay, I think I have succeeded in doing that. All right,
okay.
can you guys see my screen?
No, no, no. Your screen is not up yet.
I'm looking for the,
Present.
yes,
Yeah, present is at the bottom. In the StreamYard tab at the bottom of the screen. Have you seen it?
okay, I can see it.
Okay. Okay, you can see your screen now.
All right. All right, so today we'll be talking about cryptography, the foundation of blockchain security, blockchain developers, what they need to understand about the principles of cryptography and how to build secure application. As we all know, blockchain is an open technology where anybody can participate. You don't need permission to participate on the blockchain. However, while dealing with a user information, you don't need to expose uh, some data about the person. For instance, you don't need to expose the private key of an individual. So private key is what would make a hacker or a potential bad user to exploit your wallet and take all your assets. So I don't think we wouldn't want to do that. So that's what cryptography helps us to achieve. They are the center of security on the blockchain. Aside blockchain, they are the center of security of the modern application softwares. Without cryptography or hashing, password will be plain, on the database. So that's what we'll be exploring today. So at the end of the day, we are going to be dealing with tools like Hard Hat, Web3.js, or even EtherJS, Truffle, essential for real-world development. All right, so what you learn a cryptographic concepts, blockchain security risk, excuse me, development tools frameworks. So what are the basis of cryptography? I know many of us must have heard about hashing, encryption, and digital signatures. Those are basic concepts we use in cryptography. So hashing converts data into a fixed length. So you can have a length of 32, 64, and 255, 256. All right, so that's what hashing is all about. You convert data into a fixed length string. It's irreversible and unique to each input. So when I hash hello world, when I want to hash the next one, I shouldn't be getting the same hash string of the first hello world instance. So that's how hashing works, and it's also irreversible. You shouldn't be able to reverse a hashed data. All right. Then we also use it in block headers and transaction verification. So encryption will have AES and RSA encryption. So AES is symmetric in nature, while RSA is asymmetric in nature. So asymmetric encryption is widely used in blockchain transaction. In blockchain, we use asymmetric encryption. We also have digital signatures, which ensures originality and integrity of a data. So before you send forth your data, for instance, you send money to Mr. B from Mr. A, that process need to be digitally signed to actually verify where it is coming from. All right, so move over to the next slide. Public and private keys. So if John Doe happens to send his wallet to his friend, what John Doe is sending is the public key, which is, you know, widely known, or it's not a hidden information. So basically, a public key in context with a blockchain or cryptocurrency is our wallet address, our the address we give to people to send us token. So that is a typical example of a public key. All right. Uh, so when we create a wallet, At that instance, a private key is also created alongside public key. But private key resides on a machine, on the machine of the person that created it. You don't share it with the public. All right. So what's the essence of private key? We use private key to do some secret stuffs. Secrets used to sign transactions. That's basically at the high level what private key does. While public key is shared with everyone used to receive transaction. So example, how to generate a public private key, a public private key pair using OpenSSL. So OpenSSL is a library that is, I think, open to, it gets, if it doesn't come with our system, it can be stored on the system, Windows, Mac, Ubuntu. So once you install it, you can now run this command on the screen to generate a private and public key. I think let's. If I don't have much time, I would have shown us the how it looks like. But during our hands-on, I think we are permitted to play around it. All right. So how blockchain uses private keys? Users sign transaction with private keys. Network verifies using the public key. So what it entails is private key doesn't work in isolation. It works hand in hand with public keys. All right. So users sign transaction with private keys, then the network verifies using the public key. So the public key should be the one to say, okay, this is actually coming from this person. So talking about security, we have what we call Merkle trees and blockchain integrity. So Merkle trees data structure that ensures tamper proofing. It ensures something that is kept, it's not being tampered or edited along the process. So the job of Merkle tree is to ensure the integrity of data, ensuring that it doesn't get tampered along the way. So each transaction is hashed and combined into a Merkle root. So, you know, Merkle roots just is like a binary tree, but it's more advanced. We all know what is a binary tree, but it's more advanced than a binary tree. So, for instance, on the roots of the tree, if you have like 0, then followed by 0, 1, I'm using a binary tree as an example. So there's a snapshot of that arrangement. We have on the root 0, then the leaves, we have 0 and 1. 0 on the left leg, 1 on the right leg. Then that arrangement is now snapshots and hash and kept on the database. If anyone along the line happens to rearrange that structure, the system, the system would know. So that's what Merkle tree is all about. It ensures that arrangement is sealed. It doesn't get rearranged. It doesn't get tampered. I hope I'm making sense. All right. Why is it important? It validates transaction without downloading the entire blockchain. With Merkle tree, we can validate transaction without trying to download the header, the genesis, you know, down to the, to the tail, and before we can perform validation. with making tree, it becomes very easy to validate transaction. We use it in simplified payment verification wallets. All right. Talking about security, there is what is called a 51% attack. Just like in analogy, when we are talking about shareholders in finance banking sectors, uh, when somebody gets 51% share of your equity, that person has a major stake. That person has more say. That person could uh, become there's every likelihood the person will become the board, the chairman of the organization, or you know, he will have more say in directing the affairs of the company. So the same thing applies to blockchain. That's what is called 51% attack. So if the person, a malicious actor, control most of the network. That's why on our first class, we mentioned about diversity. Ethereum encourages more people to engage in node running. You know, so by the time we engage more in running a node on Ethereum network, it has increased a lot of surface area. The surface area becomes bigger for one person to control. So that's why it's encouraged to run, encourage users to run node. So this helps us to make it unreachable for attackers to have a greater percentage of the share. All right. So if security is not also put in check, that's what we call double spending. So that could, from our script, smart contracts could be exploited in such a way that a bad actor could double spend on the smart contract. So what I mean by that is when a transaction, for instance, Mr. A is sending transaction to Mr. B, sending 10 USD worth of assets to Mr. B. There's a way a bad actor could exploit that process if securities, some stuff have not been put in place based on how we write our smart contracts. It could lead to double spending. So instead of the person you are sending to receive the 10 USD worth assets, the person will take the 10 USD and also take more, because the process was supposed to be closed at the moment that 10 was sent. So the person could have that loophole to exploit and steal more than he's meant to get. So that's what double spending security issues all about. So that's what we call Sybil attack, creating multiple fake identities to manipulate a network. We are supposed to be seeing one person on a network or 5 person on a network. Before you know, we have like 15 persons interacting and impersonating uh, individuals. So have countermeasures like proof of work, proof of stake, and decentralized governance to tackle these issues. So we're also going to be talking about decentralized storage and oracles. So in that we have in decentralized storage, you have IPFS. So if you are observant enough, if you are using a browser like Brave has uh, decentralized storage, come with it. I want to pull out that feature from my Brave browser. possible, I will share it. All right. I think, but what I was trying to show us is if you copy an IPFS URL on the Brave browser, it recognizes it. While on the other browser, you need to put some stores to make it work. But Brave automatically and recognizes a Web3 or IPFS link, and it shows you the content that is coming from the source, the IPFS source, unlike other browsers. So IPFS is a platform for holding or storing Web3 assets or Web3, data. So instead of storing, we are talking about decentralization right now. We don't store users' information the way we store on the web too. All right, so we store them on the platform like IPFS, AWI, Ficon. So the technology behind that is the way it is done. They bring somebody's data and shred it, for instance, scatter it and encrypt it and store it on a decentralized manner. In the sense that you don't have a permanent place, one place, with a single source of truth for your data. So I think the term for that is sharing. They share the information. They also have oracles. We use it for getting price feed, fetch off-chain data for smart contracts. So have platforms like Chainlink, Pyth. So you could get information like live score, price feed, stock price. You know, if I've been making use of platforms like platform for getting price feed or current price of Bitcoin and others, probably the source is Oracle source. They are getting from Oracle. All right. So bear in mind on the Web3, we have decentralized storage and oracles. Also, oracles, talking about oracles, we also use Oracle to get uh, things like random numbers. When you want to get random numbers on the blockchain, that's what Oracle platforms are meant for too, because it's not an easy task getting a random number on the blockchain. So blockchain development frameworks, you know, one we don't want to for us to come out with a faster development process. Most of the times we don't work with the native language of the blockchain. We have tools, libraries that helps us to spin up application for prototype sake or for demoing or for proof of concepts. So have truffle, hard hat, most of them, but they do the same thing. It's just a matter of choice. You know, I've worked with truffle, I've worked with hard hats. You know, I think I prefer hard hats because it's modern development environment for testing. It has many features, testing, debugging, deploying smart contracts. So here the comparison table, ease of use, both of them are very easy to use. Performance, it depends on individual, your machine, your spec. Then debugging, for debugging, hard hat has more, hard hat is a good tool for debugging because of the plenty of libraries and the community. All right. Blockchain APIs, Web3, and EtherJS. You know, Web3.js and EtherJS, they have done a marvelous good job in exposing most of the native APIs. You know, for instance, when you want to send transaction from one point to another, you don't have to start digging deep and writing low level code with Web3. It's just a breeze, just a call a function, and you enable Web3 and send a transaction. So we used to interact with Ethereum blockchain via JSON RPC. So JSON RPC is a protocol used by the blockchain to expose some certain methods. All right, so the snippet on the screen is a typical example of how to use Web3 library to work with Ethereum. You know, it's first of all checks if Ethereum is available on the window. If it's available, it now initializes the Web3 class. From there, you can now do, you have Ethereum available to you on the window. All right, so I think Ether is more modern than me too. In terms of preference, I prefer Ether.js. All right, so before we can work with any of these, first, we need to set up our node environments, install Node.js. So once you not install Node.js, it comes with npm. So you can now check the version. So if you can see the number of the Node.js and the numbers of the npm version, that means we have successfully installed Node.js and npm on our device. We'll now go ahead to set up MetaMask. So you can install MetaMask on the browser, on your Brave or on your Chrome as an extension. You create an account and get a test Ethereum for development. All right. Um, so here is a snippet of how a smart contract looks like. So this is Solidity. As you can see, the .sol extension. So we'll be working with my token.sol. First of all, you license your scripts. You put that license there. You don't need to know what it does. Just your stuff needs to be licensed. Then I put the version of the Solidity, the compiler. The compiler you're going to be working with. So this is going to be working with 0.80 compiler version. Then use the keyword contract before your token name. You can see you have contract my token. So my contract is going to be the token, the smart contract name. So this is setting the public name to my token, the symbol MTK. MTK stands for my token. Then the total supply of the asset is 1,000. So this is how tokens are being created on a very high level. Then we are mapping address, a balance to the address. That means a particular address has a particular balance. That's what that line is doing. So at the end of the day, we have our constructor which initializes. So once you create it, it will just create the total supply to the person that created it. That's what that balance is message of sender. So the person that created this smart contract will have that 1,000 total supply of the assets. So it's not less for him to be distributing it based on how he or she deems fit. So this is a basic example of how to create a smart contract token. So after, just like we have in software, we have a SPDLC, software development lifecycle. So after developing, I think one needs to test and finally deploy. When you deploy, the users get to test the program, you get feedback, and the process continues like that. Software is breathing in the sense that there's no finishing point. You can also there's no perfect point. So it keeps on getting to using that cycle. You have your ideas, you work on your ideas, brainstorm your ideas, you develop, you design, develop, test, deploy, maintain, you follow that cycle. All right. So this is how to install hard hat, and then install hard hats on your projects. Then imagine NPS hard hats that uh, brings the boilerplate. Now you need to start working with hard hats. So at the end of the day, after writing your program, you now compile, do NPS hard hat compile, you compile the program, then you run your scripts to deploy it on the local hosts or test nets or the main net. So depending on the network you are working with, that is what will determine what to put on that last flag. So if it is on development level on your machine, you put localhost, nobody sees it. But if you want people to see it, you use testnet or mainnet. Testnet, you don't use real assets, but on the mainnet, you're gonna buy the real Ethereum assets. Depending on the blockchain you are working with, you now deploy on that network. All right, so how do we interact with blockchain using Web3? Sending Ethereum using Web3. Remember on our previous slide, where we instantiate the Web3 library, then we have uh, Ethereum accessible on the browser. So with that, you can now do web3.it.send transaction. So it accepts this configuration. I have a from who to who, then the value of what you're sending. So this is a typical example of how to send transaction. Sender address, receiver address, and the value. So now convert. So you don't just send, we don't send the value, the blockchain, the value of the Ethereum blockchain. I'm using Ethereum as an instance right now. The value to understand is not your sans, what we call uh, you don't put uh, any amount of money like that. You need to put the main units of Ethereum is on stand. That's why you have that web2.eth.2v. You should convert it to V. So that to V will not give you, so 1 ether of to V will not have, I think Ethereum uses 16 zeros. You know, so at the end of the day, Ethereum will see it like 10000000000. So now on the this is 1 ether. All right. All right. So this is where we draw the curtain for today. So let's recap. Uh, I think the key takeaway is cryptography ensures blockchain security. So without cryptography, there is no security on the blockchain. And that's the starting point is cryptography, hash, since data. You know, then smart contracts run Ethereum and other blockchains. Use smart contract to write your programs on Ethereum. And the language Ethereum uses is Solidity. So Ethereum uses Solidity to write its smart contracts. Other blockchain uses the one convenient for them. Then the tools we use, so have tools like HardHat, Web3.js to simplify development. All right, so I'm going to be sharing on the charts, the hands-on, and the resources for this week for us to play with. All right, so next test is going to be we experiment with testnets, Gole, Sequoia. So we have some testnets popping up. We have testnets like Holinsky and there's this recent one. Uh, so explore decentralized apps. We play with decentralized applications and see how it's built, their functions, the UI, contribute to open source blockchain. Very important if you want to take your foot out there. Open source is the ground zero or the the sure chance opportunity for any person beginners to you know, start knowing what is happening around blockchain projects. Right. I guess that's where we'll draw the curtain for today. So I'll be sharing the resources for this week's hands-on. So thank you guys for having me. If you have any question, I'm here to take them.
Thank you very much, sir. Thank you. Today I think this is the first time I was hearing about the 21% attack style. Like, wow.
Okay.
Yeah, I didn't know that there was something like that before. And that was the crazy way to attack something. Only 15% of, like, more than half of it. Wow. All right, so you guys can drop your questions in the chats if you have any question. So before we end the session, so we can answer your questions. And also, don't forget to join the Discord channel. I've dropped the link in the email, and I'll also be sending the recorded session to your email as well. So we're waiting for your questions. And while we wait, you can also follow our Twitter channel, Africinnovate. Follow us on Twitter, Facebook, and join our Discord channel from there. Okay, I'm not getting any questions, so I don't think we have further questions.
Okay. I've dropped the resources for what we covered today.
Okay. All right, so our next session will be coming up next week, Thursday. So at least before Thursday, you would have covered majority of what we have here. And from there, you'll be able to understand what we're doing better. So very soon, we'll be starting the hands-on session where you can actually learn to build the your own build with Solidity yourself. So, all right, so see you next week. Thank you for joining us today, and bye.
Yeah. Yeah, bye, guys.
All right,
Thank
take care,
you.
guys.